Welcome everyone to this session of the fourth season of The Next Show.
Hi everyone, great to see you again.
Fantastic that you are here to listen to our latest speaker, James Bridle.
Yes, our guest this week is James Bridle, and they are a technologist and artist. And in their latest book, Ways of Being, they look at non-human forms of intelligence. So get ready to have your mind blown by James.
And we invited them, as several other speakers, to talk about Hug the System, which is our theme for the next conference this year. And we want to talk about systems that help or hinder us and that we want to change from the within, ideally. That's why we want to hug things.
Yes.
And you have a thought to share.
Yeah, I saw a story a couple of months ago that really piqued my interest when it comes to systems that govern our lives, and I want to share that with you right now.
Fantastic. Let's take a look.
This is a thought about AI and the great stagnation. We are living through an intelligence revolution, and I've been thinking a lot recently about how that is set to reshape the world around us, and I know we're going to hear a lot from our guests on this subject in this series. Here's a story though that really piqued my curiosity recently. Meta, or Facebook as they were, announced that an AI they've developed has invented a formula for a better kind of concrete. This is a type of concrete that is stronger and also uses 50% less carbon in its production. And that's a huge deal because production of concrete, believe it or not, accounts for 8% of global CO2 emissions every year. At the same time I read that, I also saw another story that some researchers in the United States have used AI to develop an enzyme that eats plastics 3 times faster than the best enzyme that we have engineered so far to eat plastics. Now look, there's a huge question about innovation across the last few decades. We all know we've lived through a revolution when it comes to the world of bits. We've lived through a digital innovation revolution, but there's been no according revolution in the world of atoms, in the world of material around us, the world of stuff, physical innovation. In fact, 20, 30 years ago, it was possible to fly from London, my hometown, to New York on a supersonic passenger jet, and now you can't. So sometimes it feels like we're actually going backwards. Some people call that the great stagnation. It's this idea that there has been a decline, maybe even a kind of halt, in the pace of innovation when it comes to the physical world around us. And there are huge hopes now that AI can change all this, that AI can be the force that kicks us out of the great stagnation. And it can do that by developing models and plans and formulas and more that we can't develop on our own. I'll give you one example of what I mean. There's a US startup right now called Boomjet, and they are developing a new kind of supersonic passenger jet. Now, a big part of the reason Concorde didn't work out in the end is because it wasn't very fuel efficient. It was very expensive to fly Concorde. Back in the 60s when Concorde was built, if you wanted to run air resistance tests, those tests were hugely expensive. You had to build the physical model, you had to build the physical Concorde, put it in a huge air tunnel and run the test this way. Boomjet have been able to run millions of virtual tests using virtual models and using AI to crunch all that data. So they have developed a supersonic passenger jet that is radically more fuel efficient, and that means it's economically viable. They've used AI to solve a problem that we couldn't solve on our own, and that's the big hope for AI and the great stagnation, that it can solve problems we simply can't solve on our own. Some believe we can even use AI to solve the biggest shared challenge we face, and that is climate change. Can we use AI to make buildings that are radically more energy efficient? Can we use AI to develop technologies that cool the planet or suck carbon out of the atmosphere? We've just lived with the pandemic through a really powerful lesson in fragility. Global supply chains, the global economy, these are fragile systems. They can be damaged, they can collapse even. We need to adapt these systems around a changing world. We need to adapt them around climate change. And perhaps AI is the best chance, perhaps it's the only chance we really have of doing that. Perhaps we can use AI to solve some of these hugely complex system challenges that we face that we can't solve alone. There are, of course, huge risks associated with all of this. Who controls the AIs? Will future systems be governed by AIs that we can't really understand, so the future feels kind of out of our control? But we often tend to think that if we're thinking a lot about technology, if we're thinking about AI and robotics, then perhaps we're not attending enough to the planetary crisis, to the climate crisis. But this meta story, this concrete story, is such a powerful reminder of the way these two things are deeply intertwined. We can't really think about climate change and the complex system that is the climate and solving that if we don't use AI as an ally.
I am delighted to have James Bridle on the show today. James is a visual artist, a writer and a technologist. Their artwork is commissioned by galleries and is exhibited around the world. Their writing is published in Wired, Guardian, Financial Times, you name it. James is the author of the book New Dark Age and has been described as the Harari Noir. James, your latest work is the book Way of Being. Thank you so much for being here today to talk about this.
Thanks very much.
I really love your wallpaper in the back. Where did you get that?
Thanks. I worked hard just to get just the right ambience going here. This is actually the spot in which I wrote the last book, so it's quite a special place for me.
Whereabouts is that?
So I live on an island called Egina, which is just off Athens in Greece.
I'm jealous, but I'm here in Hamburg, which is also very nice. So if you could tell us a little bit about your latest work, Ways of Being, which sounds a bit more positive than your book you published before that. Is that right? Or am I mistaken?
Yeah, that's certainly the case. It started from the same kind of place as New Dark Age, in looking at the ways in which we're using contemporary technologies and the apparent fact that they're not really working out the way we expected them to, and causing all kinds of problems. And I really started to expand on some of the ideas that lie behind those technologies. I'm particularly interested in things like artificial intelligence, new technologies which make very broad claims about what they can do to the world, but again, seem to be having quite surprising and perhaps risky and even dangerous effects. And really questioning what it was that we were doing wrong, really, in that. And I focused particularly at the start of the book on intelligence, why we think intelligence, if we make it ourselves in the form of artificial intelligence, might look like the things that we're building, and then what might be wrong with that idea of intelligence, how we could think about intelligence in very different ways. And really I came to the realization that all our ideas about intelligence are so focused on a very narrow idea of intelligence, which comes from human behavior and human intelligence. And if we start to look around us, we start to see all the other ways that intelligence is done by other beings that we share the planet with animals, plants, with microorganisms of all kinds, and even really with whole ecosystems and the whole Earth. And if we take those kinds of intelligence seriously, if we really start to think what we might learn from them, then we can start to sketch out a different path, not just for technology, but for the whole planet and our relationships with it.
Yeah, can you maybe share one or two examples that amazed you the most, like from sorts of intelligence that you explained in your book?
Yeah, so I mean, there's a few different ways of thinking about it, because I really broaden kind of the common definition of intelligence out quite a long way. But a couple of things that are really nice to think about. One of which is intelligence as a kind of embedded knowledge, or an enactment of an embedded knowledge that we're only just coming to understand. For the last couple of years, I've been working with scientists here in Greece who are working with plants called hyperaccumulators. And these are plants that grow in naturally metal-rich soils. And they draw the metal up into their leaves and into their stalks. And then we can harvest those plants for metal. Harvest them like a crop instead of digging them violently out of the ground with all the kind of pollution and damage that causes. And what's really extraordinary about that is that these plants, and there's many different types of these plants we're finding all around the world, they've learned to do this by growing in a very specific place over millennia. So they have this kind of knowledge of the place that humans are only starting to recognize, and they're using that knowledge to survive in those places. And we're starting to work out how we could work with them for a more sustainable way of obtaining some of the things that we need. So that's one kind of intelligence, is a kind of embedded knowledge. And then you've got something like the slime molds, which are these really extraordinary microorganisms that kind of somewhere like amoeba, somewhere between kind of plant and fungi. They're very strange little creatures, but they turn out to have incredible properties. One of the things we've realized is that they're very good at kind of mapping out networks and kind of figuring out the most efficient routes. And when researchers put them to the test on a thing called the traveling salesman problem, which is a problem that kind of baffles computer scientists and very large companies who need to solve kind of logistics problems. It's a problem of mapping routes between cities. We discovered that slime molds could solve this problem better than any supercomputer humans have ever developed. So they have an ability to solve a certain class of problems that we and machines are really, really terrible at. And those are just examples from very kind of tiny, small organisms or from plants. When you start looking at the things that other animals, and again, as I say, whole ecosystems can do, the possibilities are just extraordinary.
Yeah, absolutely. Like the slime molds examples, I saw that a map of London with those molds, and then they could even predict where the tube stations are. It was amazing, and these are used for different optimization of the city traffic, basically, which is crazy.
Yeah, exactly. And what's really important to remember about them as well is like, that's just a test we've figured out how to put to them. Like for them, it's just a party trick, right? Of course, we're interested in kind of logistics and transport networks. The slime molds are probably interested in all kinds of other things. And if we could figure out like different questions to ask them, we might be learning a whole bunch of different things along the way.
What do you think we can learn, like apart from these traffic solutions, what do you think we can learn for artificial intelligence from these kind of natural different intelligence systems?
Well, again, it's hard to say because we're only just figuring out how to answer the questions. But if you look at the way we're designing artificial intelligence in the present, there's obviously a lot more we could be doing. The kinds of artificial intelligences that we develop at the moment are largely kind of insular and competitive, by which I mean they're kind of single fixed machines that still adhere to a quite fixed model of kind of programming and development. So they step through a kind of quite fixed set of programs, even when dealing with large complex sets of data. And they're also, most of them are designed along adversarial principles, which they're designed as competitors. One of the ways we train most kind of AIs in the present is kind of building several of them and making them compete against each other.
Okay,
and if you think about that in kind of evolutionary terms, you're basically building an incredibly competitive organism. And competition isn't the only way we function in the world. And also, intelligence, as I explain in the book and through these various examples from the natural world, isn't something that kind of only exists in singular minds. It's relational. And in fact, there's also organisms, creatures like octopuses and the slime molds, that actually their intelligence is spread out kind of organically throughout their entire bodies. Or we can think of intelligence as something that exists between bodies, that exists as relationships between different creatures rather than as something that only happens inside the head. So really there's a whole pathway for all forms of intelligence, not just artificial intelligence, that starts to see intelligence as something that's distributed and something that isn't purely competitive, but actually something that's more about cooperation and relationships rather than these kind of intensely trying to outdo one another.
Where do you see artificial intelligence moving towards? You've got a background in computer sciences. Where do you see it developing towards?
I think one of the really interesting ways it might develop is firstly, to become more like natural systems in various ways. As I've said, to start looking at kind of other models of cognition from non-humans, from plants and animals, and also to operate in more cooperative, collaborative ways. For example, a really beautiful example I think of this is that there's a project being done in a thing that I wrote about in the book called the Internet of Animals, which is using large-scale animal tracking to understand things about the natural world that weren't visible to us before. There's an amazing project based in Germany at one of the Max Planck Institutes, which uses animal tracking to predict earthquakes. So this has been known in kind of folk knowledge for a long time, that animals exhibit unusual behavior for approaching earthquakes. And this has now been shown to be predictable if you track the movement of the animals using little kind of accelerometer tags and using GPS and things like this. But what's super interesting is that those patterns, even though we sort of thought they should be there, you couldn't just look at the data as a human and see and to be able to predict so closely. And what they used was machine learning algorithms that were actually originally developed for financial systems, for tracking stock market movements, right? So the most kind of predatory, aggressive algorithms you could think of, when tuned to like pay attention to the behavior of animals, were also capable of picking up this data that predicted earthquakes. And this is what I mean by kind of redirecting some of this intelligence away from these purely kind of competitive aims towards something that's more collaborative and aware of the natural world around it. But also I think it's really crucial, or a thing that I came to understand, is that, you know, the role of AI is also probably not just to like help us to achieve things or to understand things or to dominate them, right? Which is how we tend to use most of our technologies. It's also a gateway to understanding the world differently. Because for such a long time, we've really seen human intelligence as being the pinnacle of any form of intelligence. We've almost refused to admit that any other forms of intelligence exist at all. But just at the moment that we're so obsessed with this idea of artificial intelligence, we're also slowly becoming aware of all the other intelligences, all the other ways of thinking that surround us. And so for me, artificial intelligence is not just a tool, it's a kind of hint or a gateway to recognizing that human intelligence isn't the only game in town. And in fact, there are multiple forms of intelligence and multiple ways of being and doing intelligence all around us. And AI really might also function as just a kind of an introduction to that, to make us more aware and more sensitive to the world around us.
And also to our place in this whole system. So not
Absolutely.
Us being separated from the nature, but being a part of the system.
Absolutely. We're all completely entangled with the world around us, and artificial intelligence is part of that entanglement. I increasingly hesitate to even call it artificial, because it is intelligence. It is a form of intelligence that is a product of evolution and the world and the earth as much as we are and everything else we share it with.
That's a very interesting take on it. I mean, obviously it's man-made or humanity-made.
But nothing that we make is purely man-made. It is made out of the earth itself. Even the computers that we're talking through right now are made of minerals out of the earth.
Yeah,
and they're
right.
made of electrons and everything else. We are all part of a much greater, more than human world.
To my understanding, this kind of connection is part of your work, not only in your writing, but also in your artwork. And you are exhibiting at the moment in Berlin. Could you tell me just a little bit about that exhibition and what made you do these objects that are exhibited there?
Yeah, so the exhibition that's on in Berlin at the moment at Nome Gallery, it's called Signs of Life, which is really, you know, also a slightly optimistic title, hoping towards perhaps where we might head in the future. And the works are very different to a lot of my previous work, or at least they appear to be at first glance, because they're quite solid and physical. They're all working objects. There's a windmill, there's a number of solar panels, and there's also a huge battery made out of lemons.
Yeah, I love that one.
And the common thread between these works is, well, first of all, they all work. They're all functioning objects. The solar panels generate electricity. I've used the windmill to charge my phone. The lemon battery actually generates like 70 volts. And for me, it's really important that if one is making work about ecology, about the environment, about our relationships with the modern human world, a really crucial subject, at least I think so, in the present. You know, it's not enough just to make work kind of about that. It has to be engaged with it. It has to function. It has to do something. And so each of these works really functions. You can do something with it. They're also quite intensely DIY projects, which, you know, throughout my work, all the way through, you know, the last decade of work on networks and computers and technology, I've always tried to stress that it's really important that everybody has access to these tools. That everyone, if not, you don't necessarily even have to learn to fully program, but you should know how the machines and the things around you function so that you can use them better. This is a very strong kind of DIY ethos, that if you learn how things work and you're capable of building them yourselves, then you have more power and agency over them. And the more people have that power and agency, the more that power and agency is distributed, the more power itself literally is is distributed amongst a greater and greater number of people. And so that to counter the kind of decentralization, rather the centralization of power that tends to happen through technologies. And finally, each of the works kind of emphasizes as well our dependence and interrelationship with the more than human world. The windmill and the is explicitly a kind of regenerative wind power tool to move us away from kind of fossil fuel dependencies. The lemon battery stresses the fact that the things that we're seeking to do to generate and store energy are already being done incredibly powerfully by natural systems. The lemons, which in the exhibition are specifically Greek lemons ripened under the Greek sun, are solar batteries. They've stored the energy of the sun. And finally, the solar panels are, as I say, fully functioning solar panels onto which I've engraved images of microscopic sea creatures called radiolaria, which are these extraordinary little beings, a bit like plankton, but which build incredibly complex exoskeletons out of silicon. And what scientists have shown, what researchers in optics have shown, is that by engraving particular patterns onto solar panels, you can actually increase their efficiency by trapping certain frequencies of light that would otherwise be reflected, which for me is like an incredible both metaphor and reality of the role of kind of artistic imagination and new ways of engaging with these technologies, beyond seeing them as kind of purely technological artifacts, but as things that we can kind of reimagine and expand their use in creative ways.
Yeah, thank you so much. That was an amazing insights in this conversation, and I recommend to read the book because I think there will be so much more examples in it. So thanks a lot for this, but we are not done yet. I'm playing our little game with you. So imagine this. It is the near future. Amid an acute crisis on planet Earth, which is not too hard to imagine right now, a crack team of technologists starts with a daring plan and a new chapter of humanity. Together with 1,000 pioneers, they will travel to the planet next one to establish a new home, a base for human beings. Thanks to your outstanding achievements in the field of innovation, technology and arts, you have been chosen to be amongst those pioneers. But before you may board the space shuttle, you have to answer 5 questions. Question number 1, what is the luxury object that you would take to your new home?
I do just want to preface this by saying that I'm incredibly deeply opposed to this proposal. I think that all our narratives of kind of space colonialism that are in vogue at the moment are incredibly damaging to real attempts to change the situation here on Earth. I'm very happy to play along, but I'm very suspicious of these kind of narratives of escape rather than a focus on the present. So perhaps my answers will at least kind of draw that to attention in some way. I wasn't sure about a luxury physical object, but I know the physical object that I currently most treasure, which is that I recently bought a really good saw. It's a battery-powered circular saw. It's changed my life, and it's better than any computer that I've ever owned. But the thing I'd really like to take with me is a really good Japanese hand saw. Japanese craftsmen use these incredibly beautiful pull saws. I want one called a Dazuki to take with me, because I'm pretty sure it'll come in handy wherever I am.
Absolutely, and especially if you're a DIY person, we can use your help. What book should everyone read before boarding the space shuttle?
I thought of a few ones, but I think the best one to pick might be Kim Stanley Robinson's Aurora, which tells the story of a generation starship, which involves a huge journey of a kind of life raft to another planet, much like the one you're envisaging, and explores how human society is placed under stress by such a journey, and ultimately realizes that it's a futile one, and that what is necessary is to return to Earth and solve problems there before going elsewhere.
Yeah, that sounds perfect. What exceptional person would you like to take onto the journey?
Well, again, I wouldn't want to put anywhere. I don't particularly want to go or send anyone else, and I don't want to lose her. But someone who deserves attention and learning from in the present, I'd say Suzanne Simard, whose recent book, Finding the Mother Tree, will tell you an incredible amount about the discoveries we're making about the world around us and the life of other organisms on this planet. It's a really extraordinary work that I urge you to read.
Thank you for that hint. Could you create one law that bans something from the new planet forever?
Well, one that we should be, and are trying to implement here, which is that there should be no single-use anything. No tool, no substance, nothing that we make should be discardable. It all should be remakeable, reusable, recyclable. We need to learn not to create so much waste and to reuse what we have, and making that a starting principle of any new community would be a good one.
Yeah, absolutely agree. And could you name one tradition that you would like to take from planet Earth?
Yeah, absolutely. In the new book, I write quite a lot about a thing called sortition, which is election by lot, the political process of assigning positions of power, not by voting, but by choosing people at random. It's been incredibly successful at various points in history, and it needs to be reinstated as soon as possible.
Fantastic idea. And also thank you for pointing out that moving to a different planet doesn't solve our problems here. So we take that into account. Thank you so much for this enlightening conversation, and I hope to meet you in Hamburg at some point.
Thanks very much. I hope to attend soon.
Thank you. Thank you for being our guest today, and thank you for watching. Also, I would like to thank our partners, Accenture Song and Factor 3 for their support. I'd love to see you again at the next conference in September in Hamburg, in real life, so to speak. If you want to be part of it, simply apply for a ticket on our website. Hope to see you there. Bye-bye.